Thank you for the invitation to speak here at NANOFORUM in Torino. Wonderful, beautiful weather you have here today. And the topic of my talk is NANOIMPACTNET. What is NANOIMPACTNET? This is a network for research funded by the European Commission. And our goal is to help create a healthy and safe future with nanotechnologies. So it's supposed to be a support to get faster forward with the knowledge on the impact so that we address this topic at the moment where we are still in the research state and before we have already started all the big production. Now, starting point. You often hear citizens, also politicians, money givers, like banks and insurances ask, are nanomaterials safe? And we probably all now are aware that's not just the single question we should ask, but we should ask, starting at birth of the particles, production of the particles, production of the materials using particles, throughout the use and all the way to the end of life of a certain product. What happens to humans? Do we get exposure through air, through liquids, through food? And do we have, at one of these steps, release into the environment? And then we ask, what happens there? What is the impact? Impact can be positive, it can be negative. Let's think of all the nanomedicine that is produced. It's very obvious that there can be positive impact. My background is occupational health. And that shouldn't go backwards. Well, I'll just use the arrows, that's easier. Okay, so what about our own health? Us, the researchers. We studied last year one of the large nanotech research universities of Switzerland, EPFL, that's the Swiss Federal Institute of Technology in Lausanne, and we realized how advanced those researchers are with what they are doing and how little they knew about the occupational health effects, about occupational precautionary measures. So I'll present you some research questions that have an impact on occupational health to then afterwards show how we bring this together for other research fields that are interested in the health and environmental impact. So, in occupational health, basically, we heard already more detailed talk from Enrico about the steps to control risk. So first, you gather information, then you assess the risk, you apply control strategies and hierarchies, you do a health surveillance for those people that are at the elevated risk, and finally, if you're a company or otherwise a responsible scientist, you are interested in what's happening with the stuff once it leaves my lab, once it leaves our factory. So risk in general, you know now this scheme, there is one axis exposure, one axis is hazard, and in an ideal case, we can exactly say where are our risks for different materials, for different procedures, for different steps in our production. Each of these cases you could put an X there, and then we know how far we are from the desired place, so how much we need to put effort into reducing the risk. And then, of course, we can do some measures, either reduce the exposure or reduce the hazard, or both. In a case of uncertainty, like with the asbestos, we are more presented with a foggy situation where we can guess some of the parameters, some we know pretty clear. And that's just to remember that in such a case, we don't focus on the center of gravity, but we focus, of course, on the worst case. That's a well-established procedure. All those of you working closely together with chemical industry are aware of this. So when we want to assess risk, we basically, for this type of assessment, we categorize hazards and exposure. So let's talk about exposure first. Current measurement equipment is expensive, large, complicated. This is about 100,000 Swiss francs, 60,000 euros worth of equipment on our IST special baby cart. I know you produce here in Torino wonderful cars that cost about as much as this stuff, and they look really much nicer. So what we need is basically, we need small, cheap instruments, simple protocols to measure workplace exposure. Research projects like this, they are going on. What is still a little bit in the uncertainty is how we get like a common European approach, so that we use like the same exposure protocol, so that we can later pool the exposure data that we generate to compare data, to make meta-analysis, to enable occupational health studies that have low noise on the exposure side. So when we categorize the risk of particles, we can also check the hazard. We can first say, well, when we have biopersistent fibers, we say caution. Reactivity particles, we say caution. When low reactivity, say, well, we still analyze the risk. We can also check the exposure. We say high exposure, caution. There's one big or small, depending on how you see it, problem with this. What is high exposure for nano? So we can't just go to the TLV table and say, okay, the occupational limit is this high, so we are well below, we are fine, or we are above the limit, we have to do immediate action. So we need to come up with some tools right now already. When we want to do occupational health for research labs, we can't wait until we have all the tox data. Especially we don't want to wait until we have epi data, because epidemiological data from occupational fields means that we get data from researchers that got sick, and we don't want to get sick, right? Okay, so one approach is analogy. We compare to establish risks. So we say, well, asbestos fibers are long and biopersistent, so as soon as we work with long persistent fibers, we just say when we reach the occupational limits for fibers, asbestos fiber, about a range of 0.1 maybe to 1 fiber per cubic centimeter, then we say we are too high. We can compare the other thing to diesel particles, which we know they are moderately active particles, reactive, and in some countries we have 100 microgram per cubic meter as an occupational limit for diesel particles, and 100 microgram of diesel particle corresponds to about 50,000 particles per cubic centimeter. So again, well, when we reach that, we start to talk about high particles. We can say, well, we know these particles are extremely reactive. Think of copper particles, they are very reactive. So let's just add a safety factor. And pure guessing, let's just take a factor of 10. And then we still say, well, as soon as they are sensitizers, hormone-like and so on, we need to do additional thinking, what do we want to accept? But common to all of these approaches is facts are better than analogies. So we want to make forward fast with creating facts about what is going on of this. And as Ivana mentioned, we need protocols that are not biased, that are not confounded by the fact that these are nanoparticles, and that give us really the true answer. And if possible, we get like protocols that we somehow can compare, even better if we can somehow harmonize our protocols. So once we know the risks, we apply the stop principle. What is stop? S like substitution. If we know we have something really hazardous, we either check, can we replace the particle by something less hazardous? Well, we want to work with nanoparticles, so we can't really replace the nanoparticles. Maybe we can change the structure. If we can't do that because we want to study that structure, Well, how about moving from powder quite soon to liquid, paste, non-brittle solids? So basically remove the potential that we get exposure through the air, because that's the most dangerous route of uptake. The T of the STOP principle, that's technology. We just basically separate the worker from the hazard. So like glove boxes, fume hoods, or at least local ventilation. And we of course don't forget, that should come later. This should come. We shouldn't forget about the rest of the company or of the university. So we should think of where can the particles go to the rest. So maybe we need a low pressure lab. We should think of where are the particles going. There was a lab that contaminated the rest of the building with radioactively labeled particles. The whole building was closed because of one little incident, because they had forgotten to put a filter in the outlet of their fume hood, and the inlet of the circulation brought everything back. So these are established technologies. And organization, of course, we need to reduce interaction with the hazard by organizational measures. Also, Enrico already mentioned this nicely. And here again the question, what is the impact of nanoparticles characteristics? Again, we need harmonization of our approaches so that we can really compare what company A is doing, what company B is doing, what research lab A, B, C, D are doing. The last resort in the STOP, that's the P, personal protective equipment. Enrico already mentioned this is the last resort. You can consider the case where you work with liquids that are corrosive in the lab. Quite evidently, you don't put on gloves and go into a liquid with corrosive substances. You take tweezers and use those to manipulate stuff. So your glove is not really that you put on when you work with the corrosive substance. That's for the case of a spill. It's not to protect you while having direct contact. That's the normal case. Well, I mentioned here already some of the research that was done on nanoparticles. Filters, they do work. If you take high efficiency filters, eyes, they need protection, full mask or goggles like diving goggles. Gloves, they get some penetration, you need double gloving, and woven material does not protect you from particles. They can go through, they can deposit on your normal clothes, so if you work in critical situations, still put on that stuff. And this last note is just important. If you need personal protective equipment because otherwise you would have too high exposure, then something is wrong with your management, or most likely. There are cases where it's not the case, but in most cases, the need to reach acceptable levels of exposure, that's a sign of management failure. So, the last issue that we always have to deal with, occupational health, that's the release of nanoparticles into the environment. And also here, we need indications of how to control emissions, and where do these nanoparticles go, and what will they do in the environment? Well, we don't need to know that much in the occupational setting, but if you are now looking at another researcher being in the environmental field, environmental ecotox or environmental systems analysis, then these are the central questions for these people. So I'm making now the transfer to the fields of knowledge that we need if we want to study the health and environmental impact of nanomaterials. So we need to understand human exposure and health. We need protocols in this field. We need to understand environmental fate and hazards. We need to know how to combine these in the impact assessment strategies, especially the question, how do we deal with all these uncertainties that are around? How do we deal with like every day being like several papers, as Biche mentioned, being published that bring completely new data, sometimes completely reversing what other people published before. Let's think of the fullerene case, where earliest papers said they are highly toxic, and then suddenly we realized it's the way that they were put into solution with fluoridic acids, basically, that then were extremely toxic functional groups. So no, fullerenes are not really very toxic. It's the opposite. They are quite low toxicity. So such findings, we need to address them, and we can't just each time restart our full analysis. So we need to have a smart way to do the impact assessment. And we need to integrate all this data. We need to have a common language, which is called nomenclature, and we need to think also of all the ethical, legal, societal impact and issues that are around. So what can we really justify to sell or give to other people? What will the lawyers tell us? And then, of course, we need to communicate all of this with other researchers, with the population, with industry, with governments. So it's quite a large field. And all of this, we need research coordination. And so European Commission grants us for the next 3 years still, we already run 1 year, grants us, that's NANOIMPACTNET, the European Network on the Health and Environmental Impact of Nanomaterials. They grant us quite some money to bring people together to discuss best approaches to do this, to come up with joint protocols, and to find a common language. So how are we going to do this? I think I'll try to be short. So NANOIMPACTNET is first of all a research network. We bring together researchers to define knowledge gaps, to think about joint strategies to get funding, and to find answers to emerging new questions. We want to share and comment protocols that other people are doing. We want to facilitate the collaboration between projects. You usually don't get money to collaborate with other projects when you write a grant proposal. They will say you don't need this, or this is your own business how you do that. And just in general, we want this networking communication that is going on when you go to the coffee place and just discuss with the people next to you and what are you doing, and and you have some new project ideas. So we want to collaborate to achieve excellence in science. And if we are doing good science, then we make something which is good for everybody, for industry, workers, consumers, and the environment. So how do we work? NANOIMPACTNET has a series of workshops through 4 years until 2012, where we brainstorm, define strategies. We then collaborate over the internet to mature these ideas, and then they will, on one hand, go into reports and joint protocols, which we publish openly. Recommendations for protocols, recommendations for research strategies, for minimal metrics, and so on. And the other thing is training schools, where we bring our PhD students, postdocs, personnel on a common ground so that they speak a common language. And from my perspective, or from my experience, even more important, they will know each other. If your PhD students know each other, they will automatically start networking on their own also. So this is good for your research lab, because you have then, through your students, a contact with all the different labs that you could never do yourself with all the limited time that we have available. So one more view on sharing protocols. Standard procedure: when somebody develops a protocol, they make a protocol and then they publish results made with this protocol. Quite rarely nowadays we publish really the full protocol, but just like the core idea. So if lab B wants to compare results, it's kind of difficult. You can't just take the paper and say, okay, I do the same as the other group, but you can just, you understand, yes, it works. So it takes a lot of time to establish your own protocol, really all the timing issues and so on. So wouldn't it be nice if you could have just a full protocol from the other lab? If you're really interested in protocol, okay, you write them and you ask in collaboration and so on, but it's kind of time consuming if you want just to test like several different protocols. Wouldn't it be nice if there were a database where you can share the protocols? You say, hey, this is my protocol, it is published, so I want people to use it because each time they use my method, they will quote my paper. This is good for my quotation index. For the lab B, they will realize, hey, there is some stuff that could be done better or that we don't really understand in this protocol. So they want to comment back. Of course, if you have bilateral relation, you do it anyway. And then, last, you want to improve. Again, like in the idea of open access, if many people study the same protocol, you will get further on if everybody can contribute to improving this. So the what and how. We want published methods in NanoImpactNet. We have a website. We have this database. It's already online. Password protected, only for members. If you want to become a member of NanoImpactNet, I have handouts about NanoImpactNet and our upcoming events. Then you can access them. It's free for use. Being member in NanoImpactNet is free. You just send me a message or you register online. And of course, you apply the protocols at your own risk. So if your lab goes into flames, sorry, think first you use the protocol. So to summarize the steps within NanoImpactNet to find a common language. We started last June with protocols, with workshops on how to standardize nanoparticle metrics. This spring, we had discussions about how to handle particles in the lab. We also discussed already about how to assess the life cycle of particles. We started discussions on how to identify hazards. And we also just started on initial questions how to assess health. Once we finished all these discussions, we hopefully will be a step closer to understand the impact of nanomaterials. And here, just a forecast on upcoming events. We have a research workshop, a triple workshop in Wildhoven in October. I have handouts here about this. We have a training school for young researchers in Bratislava later this year. We still need to define the exact date. And we have next year in Lausanne a 3-day conference plus a 1-day training school about all of the issues that I just presented. And this is just our network. There are some spots missing here because it's not currently updated, and actually it's even closer to 500 right now and about 40 countries. It's just, I can't replace the slide every couple of days. So thank you for your attention.